True Projects. In this video, we are going to explain about the project, which is classifying European Court of Human Rights cases using transformer-based techniques. Coming to the introduction of the project addresses the challenge of classifying legal documents, particularly those from the European Court of Human Rights dataset, which often contains lengthy and complex text. It highlights the importance of efficient legal representation and the limitations faced by individuals in accessing legal aid, motivating the need for automated classification solutions to improve efficiency and reduce cost in the legal system. Acknowledging the effectiveness of the transformer based models like BERT and its variants in text classification tasks, the project proposes leveraging these methods for legal document classification. The ECHR dataset is used in this project. The project outlines the methodology employed, which involves using a sliding window approach to handle long documents and employing both conventional machine learning techniques like support vector machine, decision tree, naive Bayes, AdaBoost, and transformer based models like BERT, Robota, Big Bird, Electra, ExcelNet for the classification task. This approach enables comparison between traditional and the state of the art methods in legal document classification. The primary aim of the project is to develop an efficient legal documentation classifier that can accurately categorize legal documents, particularly those related to human right violations. By automating the classification process, the project aims to enhance the provision of legal aid, reduce cost, and increase the accessibility of legal assistance to individuals in need. Coming to the objective of the project, the objective is to develop an efficient classifier for legal documents, particularly those from the ECHR dataset, aiming to accurately categorize cases related to human right violation and thereby enhance legal aid provision and system efficiency. The aim is to automate the classification process to improve efficiency and reduce cost within the legal system, thereby increasing accessibility to legal aid for individuals in need. The goal is to explore the effectiveness of the transformer based models such as BERT and experience, along with conventional machine learning techniques and transfer learning in classifying legal documents to identify the most suitable approach for this task. The objective is to address the challenges posed by lengthy text and language specific domains in legal document classification by employing innovative approaches and predicting classes that are the European Court of Human Rights cases is classified as non violated case or the violated case. The aim is to evaluate all the algorithms using metrics including accuracy, precision, recall, and FN score to provide a comprehensive understanding of their performance in legal document classification, aiding in the selection of the most effective method for real world applications. To implement this project, we need software and hardware requirements. Coming to the software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. Coming to the hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. To implement this project, we have designed various steps in the flow of work. Coming to the first step, which is importing the packages. This step involves importing necessary libraries and packages that are required for the project. We imported Pandas and NumPy for data processing, Matplotlib and Seaborn for visualization, Scikit-learn for machine learning, and TensorFlow for deep learning, Flask for web development. Coming to the next step, which is exploring the dataset. In this step, the dataset containing European Court of Human Rights, which is ECHR cases, is explored. This includes understanding the structure of the dataset, examining the features, checking for missing values, and gaining insights into the distribution of the data. Coming to visualization. Visualization techniques such as histograms, bar plots, and scatter plots are employed to gain further insights into the dataset. This helps in understanding the distribution of the data, identifying patterns, and detecting outliers. Coming to the next step, which is data processing. This step involves pre-processing the dataset to prepare it for model building. It includes removing the URLs and other unwanted characters from the text data, removing punctuations to clean the text, removing stop words, which are the, is, and to reduce noise in the data, normalizing the text data by converting all the text to lowercase, removing accents, etc. Coming to the next step, which is feature extraction. Feature extraction involves transforming the processed text data into numerical features using count vectorizer that can be used by machine learning algorithms. The next step is feature selection. Feature selection aims to identify and select the most relevant features from the dataset. This helps in reducing dimensionality and improving model performance by focusing on the most important features. The next step is splitting the data into train and test. The dataset is split into training and testing sets. The training set is used to train the machine learning models, while the testing set is used to evaluate the performance of the trained models. Coming to the next step, which is building the model. In this step, machine learning models and transfer learning models are defined. The next step is training the model. Here, the selected models are trained using the training data during training. Model learns to make predictions based on the input features. The next step is Flask framework with SQLite for sign up and sign in. Flask framework is used to create a web application. SQLite database is used for user authentication purposes, allowing users to sign up and sign in into the application. The next step is user gives input. Here, user provide input through the web application interface such as entering text for the classification. The next step is given input is pre-processed for prediction. The input provided by the user is pre-processed using the same pre-processing steps applied to the dataset before model training. This ensures consistency in the data pre-processing. The next step is trained model is used for prediction. The pre-processed input data is fed into the trained machine learning model to make predictions. Coming to the next step, which is applying LDA model for topic modeling. LDA, which is latent dirichlet allocation model, is applied to the text data to discover underlying topics. This helps in understanding the themes present in the text documents. The last step is final outcome is displayed through frontend. The predictions made by the model along with any additional insights are displayed to the user through the frontend of the web application. This provides users with results of the classification task. We have used some of the algorithms from machine learning and some of the algorithms from transfer learning. Now we will know what are these algorithms. In machine learning, we have used SVM, which is support vector machine. It is a supervised machine learning algorithm used for classification and regression tasks. It works by finding the optimal hyperplane that separates different classes in the feature space. SVM aims to maximize the margin between classes, which helps in achieving better generalization and robustness to unseen data. It is commonly used for text classification tasks because it is effective in high dimensional spaces and it works well even when the number of features is much greater than the number of samples. SVM can handle both linear and non-linear classification tasks, making it suitable for a wide range of text classification problems. Coming to naive Bayes, it is a probabilistic classification algorithm based on Bayes' theorem with an assumption of independence between features. Despite its naive assumption, naive Bayes has been found to be surprisingly effective in many real-world applications, particularly in text classification tasks. Naive Bayes is often used in text classification tasks because of its simplicity, efficiency, and ability to handle large feature spaces. It works well with categorical data and it is robust to irrelevant features. Additionally, Naive Bayes tends to perform well even with small amount of training data, making it suitable for tasks where data availability is limited, such as in legal document classification. The next algorithm is decision tree. It is a supervised machine learning algorithm used for classification and regression tasks. It works by recursively partitioning the data into subsets based on the value of different attributes. At each step, the algorithm selects the attribute that best splits the data, aiming to maximize the purity of resulting subsets. Decision trees are advantageous for their simplicity and interpretability. They generate intuitive and easy to understand classification rules, which can be beneficial in legal document classification tasks where the transparency and explainability are crucial. The next algorithm is AdaBoost, which is adaptive boosting. AdaBoost is an ensemble learning method used for classification tasks. It works by combining multiple weak classifiers to create a strong classifier. In each iteration, AdaBoost adjusts the weights of incorrectly classified instances to focus more on difficult to classify examples in subsequent iterations, thereby improving overall classification performance. In the context of the project, AdaBoost can enhance the classification accuracy of legal documents by leveraging the strength of decision trees while mitigating their weakness, such as susceptibility to overfitting. Coming to transfer learning, we have used BERT, which is bidirectional encoder representations from the transformers. BERT is a transformer-based deep learning model developed by Google. It is pre-trained on large corpora of the text data using the Mars language model, which is MLM, and next sentence prediction objectives. BERT is bidirectional, which means it can understand the context of a word by looking at both left and right context simultaneously. BERT has revolutionized natural language processing tasks, including text classification. Its ability to capture bidirectional context makes it highly effective in understanding semantics and nuances of the textual data. In the context of this project, BERT is used for legal document classification tasks to leverage its powerful contextual understanding and representation learning capabilities. The next algorithm is Roberta, which is robustly optimized BERT approach. It is a variant of BERT proposed by Facebook. AI it builds upon BERT architecture with several modifications and improvements such as removing the next sentence prediction. Objective is dynamically adjusting the masking pattern during pre-training and training on larger data sets for longer durations. Roberta aims to achieve better performance and robustness compared to BERT. Roberta addresses some limitations and shortcomings of the original BERT model, such as better handling of longer documents and improved performance on downstream NLP tasks. In the project, Roberta is employed for legal document classification to leverage its enhanced capabilities and potentially achieve better classification accuracy compared to BERT. The next algorithm is BigBird. It is a variant of transformer based models designed to handle long sequences more efficiently. It introduces sparse attention mechanisms that allow the model to attend to only a subset of tokens with a sequence rather than attending to all tokens, which is computationally expensive for long sequences. BigBird also utilizes global attention to capture dependencies across distant tokens efficiently. In the project, BigBird is beneficial for handling long legal documents which are common in the domain. By efficiently processing long sequences, BigBird can capture complex relationships and dependencies with legal documents, leading to more effective classification. The next algorithm is Electra, which is efficiently learning an encoder that classifies token replacements accurately. It is a transformer based model that introduces a new pre training task called replaced token detection. Unlike BERT, which uses mass language modeling, Electra replaces a subset of tokens in the input sequence with plausible alternatives and then trains a discriminator to distinguish between the original and replaced tokens. This approach is more computationally efficient than MLM and it has been shown to achieve competitive performance. The next algorithm is ExcelNet, which is Extreme Learning Machine Network. ExcelNet is a state of the art pre trained language model introduced by researchers at Google. It builds upon the transformer architecture similar to BERT. It introduces two key innovations, which is permutation language modeling, which is PLM, and the objective and auto-regressive formulation. ExcelNet trains on the all permutations of the input tokens and leverages the auto-regressive nature of the language modeling. In the context of this project, ExcelNet can be utilized for legal document classification to leverage its advanced capabilities and potentially improve classification accuracy compared to other models. As an extension, we applied an ensemble method, voting classifier, and deep learning method to produce a more robust and accurate final prediction. Additionally, with the above as an extension, we built the front end using Flash framework for user testing with authentication. We have used accuracy, precision, recall, and FN score, which are the performance metrics to evaluate all the models built in the project. So here we have performance comparison graphs for all the metrics which are built on all the classification models. So here we have accuracy comparison graph where x-axis represents accuracy score for each algorithm and y-axis represents algorithm names. Similarly, we will have for other graphs also. Coming to the accuracy, it is the proportion of correct predictions in a classification task measuring the overall correctness of models' predictions. This is precision comparison graph. It is the ratio of true positive predictions to the total positive predictions, representing model's ability to correctly identify relevant instances while minimizing false positives. This is recall comparison graph. Recall is also known as sensitivity or true positive rate. It is the ratio of true positives to the total actual positives, measuring model's ability to capture all relevant instances without missing any. This is FN score comparison graph. It is the harmonic mean of precision and recall, offering a balanced measure that considers both false positives and false negatives, making it suitable for imbalanced datasets. The algorithm which performs well among all these metrics will be used for final prediction. To execute the project, first we have to open the code folder which contains source code files. This is the code folder of the project. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes like index.html, about.html, etc., which represent different pages of the website. This is the topic modeling Python file. This is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, integrating with the database, and generating dynamic content that to be rendered in the HTML templates. This is the notebook.ipynb file. This is the Jupyter Notebook file which contains a combination of code, graphs, and outputs all in one place. These are the model files which contain the algorithm information and that will be loaded into the project code during runtime. This is the signup file. This file is a database file used to store the user information. Now to execute the project, first we have to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we have to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. This will change current directory to the code folder's path. So here we can see that current directory is changed to the code folder's path. Now we need to compile app.py file. For that we have to give the command python space app.py and then click on enter. This command will execute Python script and perform a runtime check for any syntax errors. After running the app.py file, Flask framework will host the application locally at the default address, which is the local host, and the port, unless configured differently. Now we have to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project, which is displayed in the browser, and this is built by using the Flask framework. Here we can see an option register now. First, we need to click on that and enter all the sign up details if you are signing up newly. I have already signed up and have an account in it, so I will directly sign in. For that, click on sign in now. Here we need to provide our credentials, which are the username and the password. So I'm giving my username and the password. Now we need to click on login. We have logged in successfully and we are redirected to prediction page. Here we can see a text box wherein we need to give the input message. Based on the given input message, we will get the prediction that that message belongs to violated case or non-violated case. So here I'm entering the message. Now we will click on predict. Here we got the prediction for the given paragraph as the European Court of Human Rights cases is classified as non-violated case. And the topic for the paragraph is most dependent upon these words. Now we will try giving the other message. Click on prediction. I'm entering the other message. Click on predict. So here we got the prediction as the European Court of Human Rights cases is classified as violated case based on the given paragraph. And the topic for the paragraph is most dependent upon these words. Now we will try giving the other paragraph. Click on prediction. I have entered the message here. Click on predict. So here we got the prediction for the given paragraph as the European Court of Human Rights cases is classified as non-violated case, and the topic for the paragraph is most dependent upon these words. Now click on log out. In this way, just by giving the messages to the system, it will predict whether it is violated case or non-violated case. Conclusion of the project. The project introduces an innovative approach to classifying legal documents, leveraging transformer-based models and conventional machine learning techniques to address the complexities inherent in legal text analysis. Through extensive experimentation, the project evaluates the performance of various models, including BERT, RoBERTa, and traditional algorithms like support vector machine and naive Bayes, etc. This comprehensive evaluation provides insights into the effectiveness of different methods for legal document classification. The voting classifier algorithm, implemented as an ensemble method exhibiting strong performance in classifying legal documents. Tested in the project's front-end interface, users can input feature values to observe its accurate categorization, thus affirming its effectiveness in real-world applications. The development of an automated classification system aims to enhance the accessibility of legal aid by streamlining the document analysis process. This has the potential to reduce cost and improve efficiency within the legal system. The project opens avenues for future research in legal document classification, including the exploration of advanced transformer based models and the integration of additional features or the datasets to further improve classification accuracy and robustness.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.